Welcome to this video featuring inverse trig functions, particularly what we have called concept 4, which is when we're intermixing the trig functions that we're working with and we're dealing with specific locations on the unit circle that are known to us. So here, what we're going to do is figure out how this works. First off is the inverse cotangent of negative square root of 3. Be mindful that inverse cotangent gives us answers in the first and second quadrant. This means that the x-coordinate is larger than the y-coordinate, and it's one of our special locations, so it's going to be the angle I've put in blue on the unit circle. So we're going to replace the items that I'm highlighting in blue, the inverse cotangent of the negative square root of 3, with that angle, which is 5 pi over 6. And then this question becomes, what is the sine, or the y-coordinate, at that angle? And that's just going to be positive 1/2. So that's our answer to the question. So it's really just that simple. Keep track of what quadrant you get the output, figure out how the rest of the problem pans itself out. Next problem. Let's look at the inverse sine of negative square root of 3 over 2. Keep in mind that inverse sine gives answers in the first and fourth quadrants. We want the y-coordinate to be negative square root of 3 over 2. That's down there. So we are going to replace the inverse sine of negative square root of 3 over 2, this portion right here, with what it's equal to, which is going to be a negative pi over 3. Make sure you substitute the correct expression in there as we go, because the inverse sine is going to express it as negative pi over 3. So overall, this will become the secant of negative 7 pi over 3. We're going to have to find a coterminal angle to that. So what I would like to do is just add 6 pi over 3. That would get us back to a negative pi over 3. Oh, and ironically we're back to where we started at negative pi over 3. Secant is 1 over the x-coordinate at that spot. The x-coordinate would be 1/2. So the overall answer to this question would be a positive 2. Now we're going to look at a few more samples, and this time we're going to move the inverse to the outside of the expression. So let's say we wanted to find the inverse cosecant of the tangent of 15 pi over 4. So first thing that we're going to need to do is figure out what's coterminal to 15 pi over 4. Well, if we subtract 8 pi, that would be 7 pi over 4 that we get. Now if we think about our unit circle, 7 pi over 4, and that's what we're viewing first, we're just going to look at the fact that 7 pi over 4 on the unit circle is down here. The tangent at that spot will be negative 1, so this turns out to be the inverse cosecant of negative 1, which basically is saying, where is the y value on the unit circle equal to negative 1? That'll be down here, which means the answer to this question would be a negative pi over 2. Next problem, we're going to take the inverse sine. Now we're going to do these things one at a time. Please keep in mind that 2 is outside of our expression for the cotangent. So 11 pi over 4, what's coterminal with it? Well, let's subtract an 8 pi over 4, which gives us 3 pi over 4. So we're going to look at the unit circle. First of all, just being in mind of where 3 pi over 4 is. 3 pi over 4 is up here. The cotangent of 3 pi over 4 is negative 1. So this expression is going to turn out to be the inverse sine of negative 1/2. Remember, the inverse sine gives us answers exclusively in the first and fourth quadrants. So we want where the y value is negative 1/2, that's going to be over here, and that's going to be expressed as negative pi over 6. So that's really all we're doing. Now you might have a question about the earlier problem right here. Inverse cosecant also gives us answers in the first and fourth quadrants because it pairs up with sine. However, we really don't have to particularly worry when it's one of the so-called maybe perhaps endpoints of the circle, if we want to look at it that way. It's really not an endpoint, but the top or bottom points, the left or right hand side points, there's only one spot where that could be anyway. So keep track of where the output can be, watch the unit circle picture, and try to visualize which angle we want to achieve.